In this session, we will build the model required for this project. Here we will create the network architecture for the model. So here you can see that we are using different layers according to the features, namely convolution 2D, match spooling, flatten layer, dense layer. We have also used the dense layer as the final layer where we have used 3 neurons in that because we have 3 classes and the activation as softmax, so which is the activation function for classification problem. It provides us the probability of each class. So here we have created the model and we are using the print, we are also printing out the summary. So let's run this command and find out the summary of the model. So this is the summary of our model, which is of sequential type. It contains these layers and params of in each layer. So the total number of params in this are about 7244995, which are completely trainable. So now let's move forward where we have to compile the model. So while compiling the model, we have used loss type as categorical cross entropy, as we are working with the categorical data and it tests these 3 classes. Similarly, we have used the optimizer as Adam and matrix as accuracy. So let's run this command and compile the model. Next, we have to split the data into training and validation data set. So we are doing this using train test split. So let's do this and get the data. And the important thing here is we need to fit the model. So we have to fit the model and find out the accuracy of each epoch. So here I have used the epoch value as 50 and I have trained the data on the different epochs, and to find out the accuracy I'm using here batch size as 128. So you can change the number of epochs and put it on again and again using different number of epochs to test whether we are getting a good accuracy or not. So let's run this command. And see how a model is getting trained. As here I have used 50 epochs, so it will take around 4 to 5 minutes to get trained. So while reaching to epoch 50, the accuracy is 1, which means that the model was overfitting at that point. But as we move forward, the training accuracy is becoming 1 and the testing accuracy is becoming 1. So you can see here for this model of 50 epochs, both the accuracies are around 1. So the accuracy and the validation accuracy both are around 1. Now we will save this model. For saving this model, I have used different techniques. The first one is saving the model using H5 format. Using model.save. Similarly, we can also save the model into JSON file. This file was saved on drive with the name of plantmodel.json. And we should also save the weights of the model. Next, we will run this command and save the model. So this will save our model directly onto our drive. Next, we need to plot the training history. This will show us the accuracy of the model throughout the training. Let's visualize this. So here you can see that after 20 epochs, it was the training and validation accuracy is almost 1. To find the accuracy of the model and to evaluate it, we are using model.evaluate, and we are also printing the test accuracy. So let's run this command and see the test accuracy. So the test accuracy is 100% and the loss accuracy is negligible, like it is 0.0036, which is a very low value. So the model is doing very good. Next, we will see how the model predicts. We will pass X test to Y predict data to predict the testing data using model to predict. Let's run this command and save our predictions into ypred. We will also plot the images to compare. So let us take an image. So I have taken X test 10, which is an image. Now we will print the prediction of this, which means that we will print out the original image for this and also the predicted image. So here you can compare the original value and the predicted value by running this command. So the output is originally it is a potato early blight, and the predicted one is also potato early blight. It means that the model is accurate. So with this we came to an end of our project. Coming to the conclusion of this project, we started with loading of the data into Colab using Google Drive, and we visualized the images. Next to it, it is normalized. The images are normalized, which is important. Then we have created a CNN model. You can also create a CNN model with the same model, or you can change the number of the layers according to your requirement. So you can also change the layer, filter size, kernel size, pool size, and every other hyperparameter. This model is used for predicting the plant diseases using the images that are supplied to this one. This model is highly beneficial as it can be used by different agricultural firms and also the farmers to increase their yield and to stop the wastage of crops due to different diseases. So that's all for the project.